So a vector is represented by an arrow such that the tail of the vector represents its starting point and the head of the vector represents its direction. Please remember that the starting point of the vector, it is also called as the point of action of a vector. So this is how a vector is represented. So you can see here, so this is the tail of the vector, this is the head of the vector, and line joining this tail and head, it is also called as line of action, like this. Please remember that length of vector represents the magnitude of a vector. So it means a vectors with longer length will have more magnitude than a vectors having smaller length. So the symbol of a vector can be any alphabet like A, B, C, whatsoever you want to choose. Instead of alphabets, if you are interested in choosing special characters like alpha, beta, gamma, delta, etc. as vector quantities, even then you can take. But while taking the symbol of a vector quantity, we have to put an arrow over the head of the symbol of the vector quantity, and this arrow must always point from left to the right side. For example, we can use the symbol F vector for force, or you can use the symbols F1 vector, F2 vector, F3 vector, etc. if there are more than one forces. Similarly, for some quantity, if you are interested taking symbol as A vector for the vector, then you can use this symbol. Similarly, B vector, C vector are allowed. Even you can use alpha vector, beta vector, etc. These symbols are allowed for vector quantities. Let us take an example. Here this arrow is a vector and it is representing a force of magnitude 30 Newton, which is directed toward east direction. So the symbol of this force can be taken like this, F1 vector. So this is the correct symbol. So F1 represents the force and arrow represents that it is a vector quantity. Let us take another example. So here we have a force whose magnitude is again 30 Newton, but now the direction is actually the west. So the arrow is therefore pointing from right to the left because this direction was west and this direction was east. Now please remember that this is not the correct way to represent the symbol of such a force. Suppose this force is F2, the previous force was F1. So since the direction is from right to left, the arrow that is put over the symbol of the force should not be from right to left. Actually, this arrow should be from left to right, just like written here. So this is the correct way to represent the symbol of a force. Let us take another example. Here the velocity of an object is 70 meter per second along the north direction. So we want to write this vector quantity in the form of a symbol. So this is a wrong way to write the symbol. Although we have to put arrow over the symbol of the vector quantity, but this arrow should not be like this. Actual or the correct way to represent the velocity is this. Although the object is going in this direction, but the arrow that is used over the head of this vector quantity must be from the left to the right side. Please remember there are certain quantities whose symbols are standard. For example, P vector is a symbol for linear momentum. Similarly, V vector is used mostly for the velocity of an object. Similarly, tau vector is used for the torque. Let us take an example now. So we have to represent a displacement on a graph paper whose magnitude is 30 meter and whose direction is east. Then we have to represent a displacement of magnitude 80 meter which is directed along 30° west of south. Then we have to represent a displacement of magnitude 50 meter whose direction is northwest. First of all, we have to assume a scale of our choice. So let us assume that 10 meter displacement on the graph paper is represented by a 1 centimeter long vector. So this is not necessary. You can choose any scale of your choice. So on the graph paper, this much distance, which is of 1 centimeter length, will be representing a displacement of actually 10 meter. So here we have drawn the north, east, west, south directions. Now as per assumed scale, draw a line which is 1, 2 and 3 centimeter long along the east direction. Then draw this arrow and it will represent the first displacement which is 30 meter along the east direction. So to represent the second displacement, we will draw a line which is along the northwest direction, and we will draw markings over this line after each 1 centimeter. So this is 1, 2, 3, 4, and this is 5. So this will be a 50-meter displacement directed along the northwest direction. To represent the third displacement, we will draw a line whose length is 8 centimeter and whose angle from the south direction is 30 degree along the west. Since this line is 8 centimeter long, so as per the assumed scale, it will represent a displacement of 80 meter. And if we put an arrowhead over here, then this vector will be actually a displacement of 80 meter magnitude, which is along a direction of 30 degree west of south. So in this figure, therefore, we have shown all the three displacements. Let us take another example now. So here we want to represent a force of 3 Newton magnitude and whose direction is 30 degree east of north. Secondly, we want to represent another force of 12 Newton magnitude whose direction is 60 degree west of north. Again, we will assume some scale, and suppose we choose a scale in such a way that 3 Newton force is represented by 1 centimeter long vector. So again, as previously, we will draw north, east, west, south directions. Now draw a 1 centimeter long arrow whose inclination is 30 degree with the north toward the east direction. Put an arrowhead over this line, and this 1 centimeter long vector which is formed will therefore represent a force of 3 Newton magnitude, and its direction will be 30 degree east of north. Again draw a line of length 4 centimeter. This is 1, 2, 3 and 4 centimeter whose inclination with the north direction is 60 degree toward the west direction. And now put an arrowhead over this 4 centimeter long line. Then it will represent a vector of magnitude 12 Newton and along the direction 60 degree west of north. Thank you.